Welcome to another edition of Math for No Reason. In this edition, we will be discussing about the Fibonacci sequence, which has the first term 0, then the second term is 1, and subsequent terms are formed by summing up the previous two terms. The first term is denoted as f0, the second term is denoted as f1. So f2 is 0 plus 1, which you get 1. So f3 is 1 plus 1, that you get 2. f4 is 2 plus 1, 3. The next term is 3 plus 2, 5. Then 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21, and so on. It is known that the ancient Indian mathematician Virahanka also obtained this sequence, and he did that before Fibonacci, and therefore I have written down as Fibonacci Virahanka sequence. Our aim is to obtain a general solution in closed form for the Fibonacci number sequence. Now we will begin with a guess. So we will begin with a guess that Fn is equal to q power n, where q is a number which is different from 0, is a possible solution for representing this sequence. Now once we assume that, then from here we know that q power n has to be q power n minus 1 plus q power n minus 2. Rearranging and taking q to the power n minus 2 common, what we get is this expression. Since q is different from 0, so q to the power n minus 2 is also different from 0. So therefore, this can only be satisfied if q square minus q minus 1 is equal to 0. Now this is a simple quadratic equation, and by Virahanka's formula, we get q as 1 plus root 5 by 2, this is one root, and 1 minus root 5 by 2, this is another root. So q has two solutions, 1 plus root 5 by 2 and 1 minus root 5 by 2. So therefore, remembering this, we know that Fn is equal to 1 plus root 5 by 2 to the power n satisfies this equation, and similarly Fn is equal to 1 minus root 5 by 2 to the power n also satisfies this equation. Now since both of these expressions satisfy this equation, if we take a linear combination of that, that means if I take f1 is c into 1 plus root 5 by 2 to the power n plus c2 into 1 minus root 5 by 2 to the power n, you can quickly check that this linear combination of these two expressions also satisfy the Fibonacci sequence expression. Now we are given two starting conditions, f0 is 0 and f1 is 1. So that will help us in determining c1 and c2. So when n is 0, we get c1 plus c2 is equal to 0. And when n is 1, then note that we have c1 plus c2 by 2, which is 0 because of the previous condition. So what we will be left with is 1 is equal to root 5 by 2 c1 minus c2. Now solving, we get c1 is equal to 1 by root 5 and c2 is equal to minus 1 by root 5. So therefore, a general solution for Fn is 1 by root 5 into 1 plus root 5 by 2 to the power n minus 1 by root 5 into 1 minus root 5 by 2 to the power n, and this is true for all n greater than. So while we know that Fibonacci sequence is an integer sequence, we see the closed form representation of the Fibonacci numbers involve the irrational number root 5. Thank you.